Have you ever gazed at the night sky and marveled at the twinkling stars, pondering their origin and eventual fate? Each star that you see is a celestial mystery, a cosmic conundrum. Their existence is a testament to the wonders of the universe, a beacon of light that has traveled immense distances to reach our eyes. They seem timeless and unchanging, yet they're born and die, just like everything else in the cosmos. Stars are not just pretty dots in the night sky. They are the ultimate nuclear reactors and the architects of the universe. They build elements, radiate energy, and influence the formation of planets and galaxies. Their birth is a spectacle, and their death a cosmic fireworks show. How does this stellar journey unfold? How does a cloud of dust and gas become a glowing orb of nuclear energy? And what happens when a star exhausts its nuclear fuel? Today we are going to unravel the fascinating journey of a star from its birth to its death. Stars are born in the most serene places of the universe, known as stellar nurseries. These celestial cradles are no ordinary nurseries. They are vast, intricate, and fascinatingly radiant. They're places where interstellar matter condenses into new stars, a process that is both chaotic and beautiful. Imagine a massive cloud of dust and gas, a nebula floating in the infinite expanse of space. This nebula isn't just any cloud, but a cosmic soup of molecules and elements with a sprinkling of tiny dust particles. Over time, a part of this nebula begins to collapse under its own gravitational pull. Gravity, that fundamental force that keeps our feet on the ground, plays a crucial role here. It pulls the dust and gas together, causing the nebula to collapse. As the nebula collapses, the center begins to heat up, forming a protostar. This protostar is the embryonic stage in the life of a star, much like a seed is to a tree. As gravity continues to pull in more and more material, the pressure and temperature at the core of the protostar increase dramatically. When the temperature at the core reaches a staggering 10 million degrees, a process called nuclear fusion begins. This is where the magic happens. Hydrogen atoms in the core of the star start to come together, to fuse, forming helium. This process releases an incredible amount of energy, causing the star to shine brightly. This light fights against the gravitational pull, creating a delicate balance. The outward push of the light balances the inward pull of gravity, and the star stops collapsing. It is now a main sequence star, happily burning hydrogen into helium, releasing light and heat into the universe. And just like that, a star is born, illuminating the universe with its light. It's a process that takes millions of years, an intricate dance of gravity and light, dust and gas. A process that will repeat itself over and over in the farthest corners of the universe, in the serene spaces we call stellar nurseries. Once a star is born, it embarks on a journey of balance and energy. The life of a star, as you might imagine, is a tale of immense heat, pressure, and a constant battle against the force of gravity. At the heart of this narrative is a process known as nuclear fusion, the powerhouse of a star. Now, nuclear fusion is no ordinary process. Imagine the immense energy required to force two protons together, overcoming their natural repulsion. This is precisely what happens in the belly of a star. Under intense heat and pressure, hydrogen atoms collide and combine to form helium. This process releases an incredible amount of energy in the form of light and heat, causing stars to shine brightly in the night sky. But the energy produced by nuclear fusion does more than just make stars shine. It also plays a crucial role in maintaining the star's shape and size. You see, stars exist in a delicate state of equilibrium. On one hand, the star's own gravity is constantly trying to pull everything inward. On the other hand, the pressure from the energy produced by nuclear fusion is pushing outward. This outward push counteracts the inward pull of gravity, preventing the star from collapsing onto itself. The star's lifetime is essentially a tug-of-war between these two forces. As long as there's enough hydrogen to fuel nuclear fusion, the star can maintain its balance. Once the hydrogen starts to run out, however, things begin to change. The balance can tip, leading to the next stages of a star's life, which could be as a red giant, a white dwarf, or even a supernova. But that's a tale for another scene. For now, let's marvel at the remarkable balance that exists within a star. The same balance that enables it to shine brightly for billions of years, lighting up the cosmos and providing the energy that drives life as we know it. This delicate balance is what keeps a star shining for billions of years. All good things must come to an end, and stars are no exception. Now that we've journeyed through the birth and life of a star, let's delve into the final stages of a star's existence. Stars, much like us, have a finite amount of fuel to keep their fires burning. In a star's case, the fuel is hydrogen. As the star ages, it continues to burn through its hydrogen, fusing it into heavier elements like helium, carbon, and oxygen. Eventually, a star will burn through all its hydrogen fuel. When this happens, the star's core begins to collapse under its own gravity, causing the outer layers to expand. Now here's where things get explosive. This collapse triggers a dramatic increase in pressure and temperature, causing the heavier elements in the core to fuse. This process continues until iron is formed, a stage at which no further fusion can take place. The iron core is so heavy, so dense, that it can't withstand the gravitational force any longer. And so it collapses. In a matter of seconds, the core collapses and then rebounds, creating a shock wave that rips through the star, causing a spectacular explosion known as a supernova. This explosion is so bright that it can outshine an entire galaxy for a brief moment in time. But a star's story doesn't end with a supernova. No, it leaves behind a remnant, a final testament to its existence. This remnant can take one of three forms: a white dwarf, a neutron star, or in the case of the most massive stars, a black hole. These remnants, each fascinating in their own right, carry on the legacy of the star, a testament to the star's existence. And so, a star meets its dramatic end, leaving behind a legacy of light and matter. Its story, however, doesn't end there. It continues to influence the cosmos, contributing to the endless cycle of stellar birth and death, and reminding us of the spectacular beauty of the universe. The story of stars is a tale of birth, life, death, and rebirth. This cosmic cycle is a fundamental part of the universe's never-ending saga, continually reshaping the stellar landscape. Firstly, let's recall the birth of a star. It all begins in a stellar nursery, a dense cloud of gas and dust. Gravitational forces pull these particles together, creating a protostar. As the protostar accumulates more matter, its core temperature rises, leading to a phase of nuclear fusion. This is the moment a star is truly born, as it starts to shine brightly, converting hydrogen into helium. Stars, like humans, have a lifespan. They enjoy a long, stable period known as the main sequence, where they maintain a delicate balance between gravitational collapse and nuclear explosion. This phase can last billions of years, and it's during this time that stars like our Sun radiate the energy that fuels life on planets such as Earth. However, nothing lasts forever. As stars exhaust their nuclear fuel, they enter the final stages of their life. They expand into red giants or supergiants, then contract under their own gravity, and eventually explode in a brilliant supernova. This dramatic death releases vast amounts of energy and disperses heavy elements into the surrounding space. But here's the twist. The death of a star isn't an end, but a new beginning. The remnants of dead stars, scattered across the cosmos, can form new stars, continuing the cycle. This stellar recycling process is crucial for the universe's evolution, as it enriches the cosmic medium with heavier elements necessary for the formation of planets, and possibly life. The importance of stars in the universe cannot be overstated. They are the cosmic furnaces that forge the elements. They are the lighthouses that guide us through the dark expanse of space. They are the life-giving suns of countless worlds. The next time you gaze at the stars, remember the journey each one has undertaken from birth to death in the grand theater of the universe. The birth and death of stars is a captivating tale of cosmic life cycles. We've journeyed through the stellar nurseries where clouds of gas and dust give rise to newborn stars. We've seen the delicate balance of nuclear fusion, the heart of a star's energy. We've delved into the spectacular supernovae, the final explosive moments of a star's life and the remnants they leave behind. From the birth of a star to its eventual death, every stage is a testament to the beauty, complexity, and grandeur of our universe. It's a narrative that underscores the cyclical nature of existence, not just on our planet but across the cosmos. The universe, with its infinite wonders, beckons us to continue our exploration, to keep asking questions, to keep learning. It's a journey without an end, a story without a final chapter. And so, as we continue to gaze at the stars, we are reminded of the wonders of the universe and our place within it.